All right, guys, welcome to the video here for the August 2022 Part 2 Regents exam question review. So in this video, I'm just going to be doing the Part 2 questions. There'll be a follow-up video with Parts 3 and 4. So for the first shawl work question here on the Regents exam, remembering the Part 2 questions are only worth 2 points. There's usually not a ton of work to do for them. So for this first question, it asks us to determine the average rate of change. So as soon as we see the words average rate of change, we are thinking the average rate of change of a function is the value of the function minus a value of the function, all divided by the x values being subtracted. Basically, we're thinking of slope. Now, since this is not a linear function, we don't like to use the word slope. We like to use the word average rate of change. Now, they want us to find the average rate of change between 2 hours and 4 hours. So essentially, they're asking us to find the slope of this line, which we can find by just counting boxes on our graph, but I'm going to do it algebraically because I think it's better. So for that first point, we have the coordinates of 220. And for the second point in our average rate of change, we have the coordinate 460. So I am going to subtract the second y value minus the first y value, and I'm going to subtract the second x value minus the first x value. I'm going to divide some numbers, and I'm going to get an average rate of change of 20. That's all you needed to do for this question. The next one says to factor the expression completely. So to factor this, it has 1, 2, 3, 4 terms. This is going to be grouping. So we're going to do x squared as our first GCF, leaving us with x minus 2. We're going to take out a negative 9 to give us x minus 2. If I take out a positive 9, our two parenthesis terms won't be like terms which we don't want. So now that these two are the same, I can take out x minus 2, leaving me with x squared minus 9, which we know is still factorable to x plus 3 and x minus 3 using difference of 2 squares. That's all we needed to do. We are finished. Number 27 asks us to algebraically solve for this. So normally when we see a square root equation, we think ISS, isolate, square, solve. Well, it's already isolated, so we're ready to square. So let's square that away. That's going to give us 4x plus 1 is equal to 11 minus x squared. Now, if you're pretty good with squaring binomials, you probably could square this one out yourself. But if not, you could go ahead and make your boxes, which is how I'm going to do it just to make sure that we're all on the same page. So if we make some boxes here off to the side someplace, so we have 11, negative x, 11, and negative x. We have 121, negative 11x, negative 11x, and positive x squared. So this is going to become 4x plus 1 equals, I'm going to put the x squared term first, minus 22x plus 121. Now to solve this, no matter how we wind up doing it, it has to be equal to 0. So I'm going to subtract 4x and I'm going to subtract 1. And I'm going to get a quadratic. Now, you could do quadratic formula here if you don't like factoring or these numbers just get too big for you. But I want to try and factor it, so let's try and factor it and see what we get. Another quick trick you could do is you could go to Desmos and just see if it's factoring, not Delta Math. We want to go to Desmos. You can even just see essentially what the answers are from your graph and kind of cheat a little bit here with the factoring. So if you graph x squared minus 26x plus 121, you can see that the graph intersects the x-axis at, not 121, 120. There we go. You can see it intersects at 6 and way over here at 20. So 6 and 20 are my solutions. So when we're saying what multiplies to make 120 but adds to make negative 26, we already know the answers are negative 6 and negative 20. So when we graph this, factor this, we'll put in the negative 20 and the negative 6 because we know the solutions are going to come out to be 20 and 6. Now, the unfortunate thing about these is we have to remember to check it. So if you did all of this beautiful mathematics and got down to the two potential answers and didn't reject an answer, you're actually only getting half credit for this, 1 out of 2 points, which kind of stinks, right? So to check this, we're going to go back to Desmos and we're going to graph two sides of the equation separately. So we'll say y equals the square root of 4x plus 1, and we'll say y equals 11 minus x. And we'll see that they only intersect at one location at 6. They don't intersect over here at 20. So 20 is our rejected answer, and the only answer we get is 6. You don't have to write anything. You literally just have to cross it off like that. It's fine. Number 28 is just properties of exponents. So first thing I would do here would be I would subtract the exponents 17/8 minus 5/4. So if I do 17 over 8 minus 5 over 4, if you're not great with fractions, just use your calculator and you're going to get 7 over 8. So we'll get y to the 7 over 8 all to the negative 4, and that's all still equal to y to the nth power. Then we have to use the exponent property of power to power, so those get multiplied together. So again, if we multiply 7/8 times negative 4 in our calculator, we get negative 7 over 2 is equal to y to the nth power. I know in class we want to always make the exponents positive when it's open-ended, but this doesn't require you to because it says just find what's the power when you get y. So we have y, we have our power, so our n value is negative 7 over 2. We're done. Number 29 is a good trigonometry question. It's a real true test that you actually know what's going on regarding trigonometry. So it tells us a cosine value and it tells us it's positive. So we know that cosine is positive. And it tells us a cotangent value that's negative. So we know that tangent and its reciprocal are negative. So when we go to like the ASTC thing, we know we're talking about quadrant 4, where is positive cosine and tangent negative. So we're going to draw a quadrant 4 triangle. So we're going to have this terminating angle, right? So we have this like angle that rotates around like this, and it's going to terminate somewhere over here in quadrant 4, and that's going to allow us to drop a vertical line in to make our right triangle. So A is this big angle that comes all the way around here, but we're going to use a little reference angle in here to find this actual value of sine of A. So because we know the cosine value, we know the adjacent side is 3, and we know the hypotenuse is the square root of 10. Because we know the cotangent value, so the cotangent of A is negative 3 over 1, that tells us the tangent value, which is negative 1 over 3, because they're reciprocals. Tangent is going to be opposite over adjacent, so now we know the opposite side without even having to do Pythagorean theorem. So now we could say the sine of A. Well, the sine of A is going to be a negative number. We know that because of what quadrant we're in. And we know that sine is going to be the opposite side 1 over the hypotenuse square root of 10. That's all you had to do. Number 30 says, according to a study in a hospital, the average rate of a newborn baby is 3.39 kilograms with a standard deviation of 0.55. So we have an average, 3.39, or a mean, and we have a standard deviation, which is 0.55. It says the weights of a newborn follow closely to a normal distribution. As soon as we see this, we're thinking that bell curve. It says last year, 9,256 babies were born in a hospital. Determine to nearest integer how many babies were more than 4 kilograms. So we're talking about a bell curve. We're talking about a z-score. And that z-score is going to be the value of 4 minus the mean of 3.39 over 0.55. If we type that into our calculator, we're going to get a messy decimal, and that messy decimal is going to change to the nice fraction 61 over 55. So what we're trying to do is find the percent that's above that number. Because if I can find that proportion of the data, we can then apply that proportion to the number of babies born. So we're going from 61 over 55 all the way up to infinity on our calculator. So when we go into our calculator, we'll clear all this junk in here. We'll go to our distributions. Let's see, distributions. Here it is. We'll hit find cumulative probability because that's what we're finding. And we're going to type in 61 over 55 as our lower number so that our maximum number is infinity. And that's going to give us the decimal 0.13369 dot dot dot. So the probability that the z-score is greater than 61 over 55 is going to be 0.133695 dot dot dot. Now, if I apply this number of babies to this percentage or this proportion of data, I could say 9,256 babies times this 0.133695 dot 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 number is going to be equal to approximately how many babies we're having born that are more than 4 kilograms in weight. So we could go back to our calculator and I can highlight this number. I think I could highlight that number. I guess I can't on my calculator right now because of what mode I'm in, but you can highlight that number. So I'm going to type in 9256 and multiply it by 0.133695548, so forth. The number of decimals you're putting here really shouldn't matter past like the fourth or fifth one. It's going to round to 1,237 babies. Notice it says nearest integer, so that's like the nearest whole number, right? Number 31 is a independence test, so it's asking us if two things are independent of each other. There are 3 ways you could have done this independence test. I'm going to show you 2 of them. If you did it the third way, good for you. So we want to determine if the person is female and the person likes classic rock or independent events of each other. So the first independence test I'm going to do is going to use conditional probability. So I'm going to test, is the chances of being female the same as the chances of being female, given that you like classic rock? Essentially, what I'm testing with this independence test is I'm testing, did introducing classic rock as a given condition affect the overall chance of choosing a female from this group of people? So in this group of people, I have a total of 105 females. So if I total this whole row for females, there is 105. So there's 105 females out of a total of 215 people. Now, if I'm talking a conditional probability, that means I'm only talking about one section of this whole thing, and that would be the classic rock section. So in this classic rock section, there are 36 females out of a total of 78 people. If I type these 2 things into my calculator, I'm going to get 0.488, and that's not going to be the same as this other fraction, 0.462. It's close, but not the same. Now, this just says justify your answer, so you don't have to explain your answer, but you do have to answer the question. So you can say the events are not independent. Now, if this asks you to explain your answer, you'd have to say the events are not independent and then explain what that means. So you'd have to say something along the lines of the chances of selecting a female are affected by the fact that they like classic rock as a given condition, something along those lines. Now, the other way that you might have done this would have been instead of using conditional probability, which you also could have done the probability of classic rock and saw if this is the same as classic rock given female. That's the one I'm not going to do. If you did it that way, you got two decimals that weren't the same, and you wrote that they're not independent. Good for you. The other way you could have done it would have been using the not the conditional, the probability of end. So probability of female and classic rock. And you could have tested it against the probability of female times the probability of classic rock. So you could have used the end rule here, because remember, this rule only works if the events are independent. So if you have all the data that know these three different probabilities, you can use this rule to test the probabilities independence or not. So the chances of being female and liking classic rock, well, there's 36 female rockers out of 215 people. The probability of randomly choosing a female, well, there's 105 females out of 215 people. Notice this one is going to have no conditional probability. All the denominators will be the same. Probability of liking classic rock, there are 78 rockers, and that's out of 215. If we multiply those two decimals out and figure out what 36 over 215 is, we can see that the decimal 0.167 is not the same as the decimal 0.177. And then we'd say the same sentence, the events are not independent. All right, remember, independent events, these things would come out to be equal. Since they're not equal, they're not independent. Number 32 asks us to determine the solution set for the system of equations. If you're a good test taker, you see that and you instantly type your answers into Desmos to see where they intersect, right? Because what we're looking for here when we're talking about a system of equations is we're looking for coordinates, right? We're looking for intersections. Now, to do this, we would just set the equations equal to each other because they're both equal to y. So we'd get the equation 2x squared minus 7x plus 4 equals 11 minus 2x. And I'm going to be honest with you, if they're asking you to solve a system, it's always going to come out to be factorable. They're not going to give you one that comes out to have to use the quadratic formula. If they do, call me, blame me. I don't think it's going to happen. So if we make this equal to 0, fully expecting to do some factoring here, we have 2x squared minus 5x minus 6. No, not 6. That would be 7. Minus 7 is equal to 0. So because there is a number in front of x squared, we're going to use the AC method here. So we're going to multiply the a and the c together. We're going to say what multiplies to make negative 14 and what adds to make negative 5. And the two numbers that make that work are negative 7 and positive 2. So what we do for the AC method is we break down this middle term and then we do some grouping. So 2x squared comes down. We're going to use one of our numbers, so negative 7x. We'll then use our second number, positive 2x. We'll bring down our negative 7 and we'll stay equal to 0. We can then do some grouping. X comes out, leaving us with 2x minus 7. 2x minus 7 is what we want, but we still have to take something out of here, so we'll take out 1. Right? Taking out 1 isn't going to change anything, but it's important to have a coefficient to use for when we group. So now that both parentheses are the same, we can make our two groups, 2x minus 7 and x plus 1, giving us our answers of x equals negative 1. That's the easy one. 2x minus 7 equals 0 is a little bit more challenging. You might want to do the algebra here. So add 7 to both sides. 2x equals 7. Divide by 2. And we get x equals 7 over 2. Now, we're not done. And again, remember, this is a part 2 question. All of that algebra only got you 1 point. So to get the other point here, you have to plug those x values back into one of the original equations and find the y values. So I would use that second equation. It's easier. So if I plug in y equals 11 minus 2x. So if I plug in the x value negative 1, I have y equals 11 minus 2 times negative 1, which is going to be 13. If I plug in y equals 11 minus 2 times 7 halves, well, that's going to give us the number 4. Again, still doing all this beautiful math, you still don't have 2 out of 2 yet. You're still sitting on 1 out of 1 because it asks you to solve for the system. They want you to write your answer as coordinates. So you'd have to say the coordinates are -1, comma 13, because when I plugged in -1, I got 13, and 7 halves, or 3.5 if you're a decimal person, comma 4. Now remember, you could totally type that into Desmos and see what the answers are just by looking at intersections. So just to show that, if I get rid of all of this junk and we graph our two equations, y equals 2x squared minus 7x plus 4, and we graph y equals 11 minus 2x, we should see they intersect at the coordinate 3.5 comma 4, 7 halves comma 4. And if we scroll up here, we'll see it intersects also at -113. So we've checked our answer. We actually could have gotten that answer before we did any of this math also, just to make sure that we were on the right path. And that's it. That's our part 2 questions. Follow up for the next video on parts 3 and 4 coming soon.